Hello learners and welcome to this class. Today we are going to look at a new topic on chemical nomenclature. What is chemical nomenclature? Nomenclature is giving things names, and in this case we are talking about chemicals. By chemicals we are referring to the elements on the periodic table, the compounds that result from them, and the various molecules. So, what is nomenclature? Chemical nomenclature is a name given to naming of compounds. It is used to identify a chemical species by what it means. That is, when you are reading it loudly or when you are writing it, you can use the various chemical symbols that we will look at. It is very important for communication. That is, it distinguishes one chemical or one compound or one element of the periodic table or one molecule from the other. It also establishes the various relationships between the molecules, the compounds, and the elements of the periodic table. When we look at the periodic table, there are 114 known elements as at present. Of these 114, 11 of them are gases, and some of them include oxygen, hydrogen, helium, chlorine, nitrogen, and the stable gases, what we refer to as the group 18 elements, the neon, the argon, the xenon, radon, fluorine, and krypton. So all the other elements of the periodic table exist in solids except what we have termed as the 11 gases, and they are those that I have named. But when we look at their symbols, before the year 1814, all elements were in the form of these symbols you can see here. All of them. However, you will notice that the 114 elements cannot all be identified and distinguished using these three symbols. Therefore, a person by the name, a scientist, a chemist by the name John Jacob Berzelius, in 1779 to 1848 was able to distinguish all the elements of the periodic table using various chemical symbols. In these symbols, he used the initial letter of the element's Latin or common name in its capitalized form. What do I mean? That some of these elements, for instance, the ones that are listed in this page is the carbon, oxygen, and iodide. These are their common names. He used their first letter in capital form to give them names. However, you will notice, as we will see in following slides, that there are some elements that only exist in their Latin language form. In these Latin language forms, John Jacob used the first letter in their Latin form to identify the symbols of the elements. This practice of using the first capital letter of the English word of an element or the Latin word of the element are still being used today. For instance, look at these two elements, calcium and cobalt. If we were to use their first capital letter, they happen to share the same capital letter. John said that if there are such elements that have got the same capital letter from the start, you use the next two letters, with the first one being capital and the other one being small, and hence the formula for calcium as Ca and that of cobalt as Co. When you look at this table, I have got some of the elements, their Latin name and their symbol. When you look at the case of antimony, the Latin name is terbium, and so is the symbol that starts with the capital S. The element copper, the Latin name is copram, and the symbol is Cu. The gold, The Latin name is aurum, and so is the symbol as Au. Iron, the Latin name is ferrum, and the symbol is Fe. This, however, as I have mentioned before, does not apply for all symbols. Therefore, you need to look at the various elements on the periodic table and understand each one of their symbols, whether they are using it is based on the English word, on their English word or their Latin word. When you look at these symbols, these various elements, what do you think is the symbol of each one of them? Like in the case of hydrogen and helium, both of them share the same capital letter. So therefore, they share the same starting letter, that is H. So they couldn't possibly share a symbol. As we know, the symbol for hydrogen is H, and that of helium, we use the H and the next following letter, which is A. Hence, the symbol for helium is He. In the case of boron and barium, you will see it is the same case as hydrogen, since boron, the symbol is B, while that of barium is Ba. When you look at this table, it shows you some of the elements, their symbols, and their Latin name. And when you look like in the case of carbon, carbon does not have a Latin name, and that's why the symbol is C. When you look at the case of sulfur, sulfur does not have a Latin name, and the symbol is the first capital letter, which is S. When you look at all these others, they have got Latin names, and their Latin names also influence the symbols they are given. So, I have given you an exercise here, which is the correct symbol for copram. Remember, copram, as we have seen in the previous tables, is the Latin word for copper. So what you expect is that the first letter, which is C, is supposed to be used. But since C already represents carbon, we are going to the next letter, which is U. So we expect that the symbol for copram is Cu. When you look at question number 2, which of the following does not belong to the group argentum, aurum, kalium, and calcium? I expect you to look at this, and from the basis of whether it is a Latin word that has been used, or whether it is a Latin word that is used, whether it is English, whether we are supposed to use the first letter or the first two letters, you need to understand that for the basics for you to answer this question. When you look at the next one is which of the following elements is a solid? Remember what we said, the periodic table has got 114 elements, and out of these 114, we have got only 11 that are gases, and we named them. Look for what we did not name here. It does not belong to this group. Number 4, what is the English name for stibium? You can look up for the meaning of stibium is the Latin name for which of the 4 elements. Which of the following does not belong to the group? Question number 5. Carbon, hydrogen, nitrogen, and oxygen. You have to look at the characteristics we have talked about. Is it a gas? Is it a solid? Look at its naming. Do we use the first letter or the first two? Then you will be able to understand which of those elements that do not belong to that group. This is just for your exercise. Now let us look at chemical formulas. Chemical formulas such as this, which represents magnesium sulfate, can be divided into what we refer to as empirical, molecular, and structural formulas. The chemical symbols of each of the chemical formulas represent a compound. Like, for instance, this is magnesium sulfate. The superscript represents the mole proportion of the preceding element. For instance, when you look at the case of magnesium sulfate, is that we know that magnesium is a group 2 element and sulfate is in group 4. So when they cancel each other, when you're making chemical formulas, is that when you look at magnesium, it just have one mole. And in this case, we have got sulfur and oxygen. For sulfur, it requires 4 oxygen atoms to form a molecular compound. That's what we do when we refer to it. It can be a subscript, which is the number below. When you are writing formulas, we will consider binary ionic compounds. When I talk of binary, it means 2. And remember from previous classes, when I talk of ionic compounds, I talk of a compound that is formed of a metal and a non-metal. Usually the metal is the cation and the non-metal is the anion. The cation or the metal is positively charged, while the non-metal is negatively charged. Let us look at the ways we name these compounds. Look at the case of sodium and chloride. Sodium has got a positive charge of 1 and chloride has a negative charge of 1. And once they combine, they form what we call a sodium chloride. What has changed in the sodium and the chloride? In sodium, nothing has changed. You use the first name of the metal as it is on the periodic table. But when you look at the chloride, on the periodic table is chlorine. So we have only added the prefix, the suffix IDE, that is chloride. This is sodium plus chlorine to form sodium chloride. When you look at the case of aluminium and oxygen, aluminium is just as it is in the periodic table, and oxygen just as it is. When they form an ionic bond, they form what we call as aluminium oxide. Look at what we have done to the oxygen. We have removed the last prefix and added the IDE. So, what is it that we are talking about when we are naming ionic compounds? The first thing we have said is that ionic compounds are made of a metal and a non-metal. And in naming them, what we are calling as the binary nomenclature of ionic compounds is that the metal does not change. However, the non-metal is what changes, such that we add the suffix of IDE. Look at the case of hydrogen and chlorine. They form hydrogen chloride. The case of calcium and fluorine, they form calcium fluoride. The case of sodium and oxygen to form sodium oxide. And these are the formulas for hydrogen chloride, calcium fluoride, and sodium oxide. The naming of compounds. How is it that we identify an ionic compound from a molecular compound? Remember what we have just mentioned, that ionic compounds are made of metals and non-metals, while molecular compounds are made of 2 or more non-metals. What are the points to remember when naming a compound, like an ionic compound? Number 1 is that the order of names in a binary compound is that the first is the cation and next is the anion. That is, the metal comes first, then the non-metal. Number 2 is that the cation name is used just as it is in the periodic table, as we have seen with cases of sodium oxide and hydrogen fluoride and hydrogen chloride. Then the name of the anion or the non-metal will be made from the root of the elements in the periodic table plus the suffix IDE. As we have said, in the case of oxygen, it becomes oxide. In the case of fluorine, it becomes fluoride. In the case of chlorine, it becomes chloride. Examples. Let us look at this. This is an ionic compound made of hydrogen and sulfur. As we have said, the hydrogen remains as it is, And for the sulfur, we add IDE to form sulfide. So the compound is hydrogen sulfide. Just for your own practice, what are the formulas of these compounds based on the periodic table and their molar formation? Sodium bromide, barium phosphide, calcium oxide, lithium sulfide, aluminum bromide. You can also name these compounds. For instance, number 1 is made of magnesium and iodide. Magnesium, we said, will not change. However, iodine, you have to change to add the prefix IDE so that it becomes magnesium iodide. Number 2 is that we have potassium and oxygen. Potassium does not change. However, oxygen, we have to add the suffix IDE to form oxide. So it is potassium oxide. You can do the same for the rest of the compounds. When you look at column B, can you try to name some of these ionic compounds? When you look at A, it is made of aluminium and bromine. Aluminium doesn't change. However, in the case of bromine, we have to add IDE to form bromide. Hence, the compound is aluminium bromide. You can do this for the rest of the compounds. When you look at the next exercise, is that you have to write the formulas of the following. Barium sulfide, made of barium, and this is sulfide. You have to look on the periodic table. Which group is it? How many electrons does it require for it to gain a stable state? That way you can write the formula of the compound. Let us look at the naming of acids and bases. And for the purpose of naming of acids and bases, we will classify them into 3 categories. There are the binary acids, the ternary acids, or what we call as oxyacids. They contain oxygen and bases. Binary acids, they contain hydrogen and one of an element compound. Their names follow what we call as the hydroelementic pattern, where the element is replaced by the root name of the element. These acids contain no oxygen. Let us look at some of the examples. Here is an acid made of hydrogen and fluoride, and its name is what we are calling as hydrofluoric acid. Look at the way we are naming it, what we are calling as the hydroelementic acid. That is hydrofluoric acid. Look at the case of hydrogen and sulfide. We form what we call as hydrosulfuric acid. When we look at the case of hydrogen and bromine, they form what we call as hydrobromic acid. Some other examples include hydrofluoric acid, hydrochloric acid, hydrobromic acid, hydroiodic acid, and hydrocyanic acids. Remember, these acids exist in their aqueous form, that is, in solution form. When you look at the oxyacids, they are acids that contain oxygen. Most of them do not exist in the same form unless they are in solution form. For instance, when you look at the case of hydrogen and nitrate, they form what we call as nitric acid. When you look at the case of hydrogen and nitrous, they form what we call as nitrous acid. When you look at hydrogen and sulfate, they form sulfuric acid. Look at the naming. Is that in the non-metal compound, we are adding the IC and naming it as an acid. Look at this of hydrogen and carbon trioxide. We form what we call as carbonic acid. The case of hydrogen and phosphorus, we form what we call as Phosphoric acid. Remember, this only applies for oxyacids, acids that contain oxygen. And this is the same case for acetic acid, which can be written in this form or this form. In the case of bases, bases are simply named as ionic compounds containing hydroxide ions, as we have learned in previous classes. And what happens to the bases is just like in the case of ionic compounds, is that what happens is that the first compound does not change. Like in the case of sodium, the sodium does not change. However, we add hydroxide, which represents the basic form, which is the hydroxyl group, to form sodium hydroxide, calcium hydroxide, iron hydroxide, ammonium hydroxide. You can try this with several other elements and see how it goes. Thank you.